Suddenly what's happened, I think this has exposed your 3D imagination, no? This particular chapter. Now that yellow color is what? Cylindrical gate. There's a water. No gate into. It's asking what is the horizontal force on the gate. We'll calculate both horizontal as total force acting on the gate. We'll calculate. It's quite very simple, no? So like, so what is the projected area? This will be. Let L be the length of this, and we know all the dimensions now. So what is the projected area? The projected area will be length L and height 2r. How did it appear? It will appear like a rectangular sheet for the liquid. Sir, how the liquid will exert force? Sir, can you show the force exerted by the liquid? So at this particular point, really very difficult to manage with integration. So therefore we are bringing this logical thing. This is what the force, that the length of the arrows should increase as you move down because the pressure increases with the depth. Okay, let's come for that one. What is the horizontal force? Very easy now. What is the density of liquid? Rho G, pressure into projected area, dA. So this should be equal to rho Gy L into dy. So rho GL y dy. From where to where? No, from where to where we should integrate? I think from R to 3R. Limits, okay. But sir, like this is semicircular, so it's like a cylindrical surface. How much it will be? What is the area of cylindrical surface? Anybody? Area of the cylindrical surface? 2 pi RL is the surface area, no? I think I should write projected area pi RL. Will I agree? No, the liquid will not see curved surface. It will just see the flat surface. Area, effective area as seen by liquid. I think it's over now. No, let's get into calculation part. This will be y square by 2 R 3R. What is effect is equal to no? Rho GL by 2 I'll take outside. So this will be 3R whole square minus R square. So 4 rho GL R square. Okay, this is horizontal force. What about vertical force? Net force exerted by the liquid. This will be very interesting. How to calculate the net force, net vertical force exerted by the liquid. Again, we'll get into the problem. I will go for the weight of the liquid. The liquid which is present above the gate will exert a force. How it will be vertically down, and the liquid which is present below the gate also will exert a force. Now what shall we do? Shall we go for net resultant force? There's a liquid present. I think this diagram is very important. The liquid which is present here where is exerting a force. Vertically also or horizontally. Horizontal net resultant force we have calculated. Now the liquid present here also will exert force. So the resultant force exerted by the liquid on solid along y-axis should be equal to the density into volume immersed into G. Why to do all calculation everything directly the what is y component of force? The y component of force should be equal to density of liquid into volume immersed into. What is volume immersed? Volume of the cylinder. Half of the volume of cylinder. Volume of cylinder. Okay, now What is the volume of cylinder? Pi r square L. How do this Fi we have to show it upward. The resultant force Fi should be upward. What about Fx? Where you have to show Fx? Fx should be somewhere here. So therefore the resultant force on the gate will be somewhere in this direction. What about torque? Torque should be zero, no? Because all the forces are intersecting axis of rotation about O. Torque should be zero. So the resultant force must pass through O. There's one more condition. I think I delivered the most essential things which are needed. There's projections, all, everything. Fine. So I'll go to the next topic, accelerating fluid. One more is there, we'll discuss later on. Let me introduce to the acceleration, pressure in accelerating fluids.